In the last segment, I left you with the remainder of the double replacement and asked you to complete them on page 4. On this one, here's how we separate our ions. We recombine them in such a way that these are our valid products. We need a 2 to balance. This one, I changed to sulfuric acid, so sorry. And made K2SO4 as my valid product because potassium is a plus, sulfate is a -2, and then balanced. The last one, again, the key is dividing up into ions, making the valid products, putting them in the equation, and balancing. Segment 3 begins with combustion, and what's nice about combustion is that the 3 parts of combustion never change. Some kind of carbon compound reacts with oxygen to form CO2 and water, and as a tangential aside, it will also produce heat. We will come back to that as we go along. So these first 2 you can recognize as combustion because of these 3 parts. Then you need to balance, and these can be frustrating because the oxygen shows up in multiple places and often we get an odd number. So I always start with carbon, then go to hydrogen, then go to oxygen last. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 2 oxygens from this, 2 oxygens from the water means I have to put 4 into it, which means I need 2 O2s. Sum of the stoichiometric coefficients, 1 plus 2 plus 1 plus 2 equals 6. Now, for the sake of the videos and keeping them short, I'm going to leave the adding of the stoichiometric coefficients up to you. 2 carbons in, 2 carbons out. 3, 4, 5, 6 hydrogens in, 6 hydrogens out. 4 oxygens from the CO2, 3 oxygens from the water, and 1 oxygen comes from the carbon compound, means 6 more have to be accounted for, which means 3 O2s have to go into it. You could also write something like this: C6H12O6 combusts, and I would expect for you to know that if you see the word combusts, that means you need to add O2 and create CO2 and H2O. Start with carbon, 12, and end up with oxygen last. 12 here, 6 here, 6 have a home in the carbon compound, which means you need 12 more to find a home, which means 6. Okay? Just when it's getting easy, we'll do this one. C8, H18, plus O2, CO2, H2O. 8 carbons in, 8 carbons out, 18 hydrogens in, 18 hydrogens out. 16 oxygens from this compound, 9 from this compound, gives us the dreaded odd number. Oh well, we have to be comfortable with odd numbers. We divide it in half. Then you fix it by multiplying the whole thing by 2. 2C8, H18, plus 25 O2, 16 CO2, plus 18 H2O. And there is your balanced equation with no fractions. Okay? Again, go to your book, go to your videos, and practice. Pause the videos if you need to. Page 5. Now, redox involves flow of electrons, and we're going to come back to this, but in order for something to flow, your electrons have to go from one place to the next. Just like this, if this paperclip is an electron, in order for it to flow, I have to lose that paper clip, and that part of the paper has to gain it. Same idea with acid-base, except instead of electrons, we're going to flow protons, which we're going to An H plus we're going to call a proton. So we're going to have an H plus, and in order for it to flow, it's got to go from one place to the next. Okay, so this paper clip is the proton. So in order for it to flow, you have to have one thing that's going to lose it and something else that's going to gain it. Okay, now once you make your valid products, you must go back and balance stoichiometrically. Go back and balance if you haven't already. Well, we've double dipped on our time and we have done that, which means we are making great progress. Okay? All right, so I'm going to try a few of these for the purposes of this segment. You may wish to pause if you wish to give these a try. Otherwise, I'll try a couple of them. Then you can pause and go on to the next segment. Okay, so this one is a combination. 2 here, 3 here, and now this is balanced. This is carbon with oxygen, so this is combustion. CO2, H2O, 3 carbons in, 3 carbons out, 8 hydrogens in, 8 hydrogens out, 6 oxygens here, 4 oxygens here, means 10 went in, so we have 5 O2s coming in. By the way, don't forget to add up the stoichiometric coefficients in it each. Okay? This one is also a combo. We make magnesium oxide and not MgO2 because this is not valid. 2 oxygens in, 2 oxygens out, which means 2 magnesiums in. Okay? Fe3O4 is a unique oxygen iron compound, so I created that for you. Nonetheless, this one's easy to balance because we didn't have to predict that, and this one is also combination. Aluminum plus hydrochloric acid yields aluminum chloride, Al plus 3, Cl minus means I have to put 3 of those in. So AlCl3 is my valid formula, and hydrogen, remember, is diatomic. If you don't get those right, then you have a very hard time balancing. When you write that out, you see that this is single replacement. Okay? Now you're going to end up putting a 3 here, but then you have 3 hydrogens here and 2 hydrogens here, which is our code for 6. So we're going to go ahead and make 6. 6, 2, 3. And that solves a lot of drama, which means 2 aluminums there. Finally, on this one is also going to be single replacement, but now instead of displacing the cation, we're going to displace the anion. Chlorine will displace the bromine. K plus Cl minus means KCl is our valid product, and bromine is diatomic, so it has to come off as Br2. 2 here, 2 here. Single replacement. As always, continue to practice with problems that are recommended in your Blackboard shell, in the videos, on the YouTube videos, or any other assignments that you are being asked to do in the classroom.